Alright, so let's begin our BC Calculus review. So, we have this first limit, and so as x equals, or if x approaches 2, so the first thing we're going to do is we're going to take the value here and just substitute it in. So we have 2 squared minus 4, and 2 squared is 4, and 4 minus 4 is 0. So 0 over 2 squared is 4, plus 4 is 8. So here we could just substitute, and we get that this limit is equal to 0. Let's continue on here. So we have the limit as x goes to 3, and we could if we substituted, we'd probably get something weird. So let's see if we can factor this bottom, because I see this -3 here. And so if I factor this, we'd get x, let's assume that x minus 3 will factor out of that. And can we, and so then we can do x plus 1 here. X plus 1. And so this does factor nicely, and so now I have x minus 3. So these two terms cancel, and so now this is just going to be 1 over, and then we could substitute now, assuming x does not equal 3, but if it approaches, it will be 1 over 4. Alright, so let's see, we have one more limit. I was jumping to down here. So we have sine x, which is always oscillating between -1 and 1. So if it's at infinity, then you kind of can do something with that. But, let's see here. So this will be, sine 0 is 0, so this will be 0 over 0. So we could do some factoring if we wanted to, or we can just take the derivative of both the top and the bottom using L'Hopital's rule. So the derivative of sine x is cosine x, and the derivative of x squared is 2x, and the derivative of 3x is 3. So L'Hopital's rule says these limits will be the same. So the limit as x goes to 0, that is not an x, x goes to 0. So now we can try substituting in, because we know that cosine 0 is 1, and 1 times, or 0 times 2 is 2, but this 3, so this is actually 1/3. Alright, so this question here is a bit weird, but it's just saying what x values is it continuous at? What is it not continuous at? So x is not equal to 1 or 2, and so we need to basically see if it's continuous at 1 or 2, or if there's any other disjointments here. So let's factor this, see if anything will end up canceling. So we have x squared minus 3x plus 2, So the factors of 2 are 2 and 1. And so we could do x minus 1 and x minus 2 here. And so 3x times x minus 1. So these x minus 1s will cancel. But to see if it's continuous here, we have to substitute it back in to see if we get this negative 3 where it's supposed to be at x equals 1. So 3 times 1 is 3 over x minus 2 is negative 1. And so that is negative 3. So it is continuous at x equals 1. So I'm just going to kind of write a check there. And let's look at x is equal to negative, or x is equal to 2, because here this factors into 2. So if we substituted 2 here, there's nothing we could cancel out. So there would be a hole at x equals 1, but it's filled because of this. But this, if you graphed it, would kind of have something like that happening. There would be a vertical asymptote at x equals 2. So it is not continuous. It is, these factors do not cancel out. So not continue at x equals 2. Okay, so now we have these functions of y here, and we have these y equals something. And so what we want to do here is take the derivative of each of these. So here we have two things being multiplied together. So we keep the first function, so we write x to the 5th, and then we multiply by the derivative of the second. And so the derivative of tangent x is secant x, so, or secant squared x. So secant squared x. And so there's really no like trick, but you just have to know that. And then we're going to do the same thing, but we're going to keep the second function and multiply by the derivative of the first. And so the derivative of the first would be, we're going to use the power rule here. So we take the 5, we move it out to the front, and then subtract 1 from the exponent. So we have 5x to the 4th secant, or tangent x. Tan x. Alright. That should be it. Okay, so I'm going to rewrite this as x squared, all of this the 1/2. So x squared plus 2x minus 1 all to the 1/2. Oh. Let's see. So now we're going to take the derivative of this. And so when we take the derivative, we're going to do the outside function first. So that means take the power and move it up front. So that means we're going to have a 1 over 2. And then we're going to keep this function, but when we subtract this by 1, we move this radical down. So we're going to now keep this inside function, so x squared plus 2x minus 1. And then we have to go ahead and multiply by the derivative of the inside function. And so this is our inside function here. So we have to multiply by the derivative of that. And so we're going to say 2x plus 2. And if this was a multiple choice question, they would probably simplify this saying you don't need that 1 there because it's literally a 1. And a 2 cancels out from all of these. You can factor out the 2 and divide by it. So this is going to be x plus 1 over the square root of x squared plus 2x minus 1. So I'm just going to write the implied parentheses here. You always want to put parentheses so that whoever is grading your paper knows exactly what you mean, despite them not doing it themselves. So let's do some differentiating of this. So we're going to keep the first term, x squared. Boom. And then we're going to multiply by the derivative of the second. So the second function is sine of 1 over x. And so we're going to have to do a chain rule and a product rule here. So we're going to start with the outside function, which is sine x. And so the derivative of sine x is cosine x. And this is actually 1 over x. So you have to do 1 over x here. But for this second term, we also have to multiply by the derivative of the inside. And so if we went over here and said x to the minus 1, we took this power, moved it out front, and subtracted 1. So that would be negative x to the negative 2. And so we can put a negative sign up front and just say x squared. And so these x squareds can actually cancel out here. But we will say that for the end. And so now we can write the other one, which is sine x times the derivative, or sine of 1 over x, of 1 over x times the derivative of this function, which is 2x. And so if I wanted to write this all cleaned up and just kind of not have a negative sign to start off with, you'd have 2x sine of 1 over x, 1 over x, minus, these x squareds cancels out, but you still have to have this minus sign. So you have cosine of 1 over x. Alright, let's take some more derivatives. So we have e to the x times cosine 2x. I'm just going to assume the parentheses are there, and that's how I'm going to work this problem. So let's keep the first function. I think that says e to the negative x. So e to the negative x times the derivative of cosine x, which is negative sine x. And the inside function is 2x, so we're going to have to multiply by the derivative of that, which is 2. Let's make it a fancy 2. Alright, and then we're going to add the second function, which is cosine 2x. Cosine 2x times the derivative of the second, which is going to be negative e to the minus x. And so you could go work this out by pulling out a negative e to the x and whatever, but this is simplified enough. If it was a multiple choice, I guess we will simplify it here. So we're going to have negative e to the minus x. And so that will just leave 2 sine x, or 2 sine 2x, plus cosine 2x. So you just need to know how to kind of simplify your answers for multiple choice questions. If you don't get exactly what the multiple choice questions have, you may not have done it wrong. You just may not have simplified. But for response questions, you don't gotta simplify. Alright. So I'm just going to have my negative 1/2 here. Not negative 1/2, it was 1/2. And so now we're going to take the derivative. And so the derivative of arcsine is going to be 1 over a square root of 1 minus x squared. Square root of 1 minus x squared. And these very rarely come up, but it's still kind of a good idea to know these trig derivatives here. And so then we're going to multiply, or we're going to actually subtract, because this is minus so the derivative of this, we're just going to keep this minus over here. And so the derivative of this is going to be 1/2 the radical down here, 1 minus x squared, times the derivative of inside, so that's going to be times negative 2x. And so these 2's and these negatives will cancel here. And so this is just going to be positive. So the final will be 1 over 1 minus x squared. It's actually kind of cool how these radicals are the same. And so let's see here. Oh, this is, you don't need this 1 here. It's just 2x. Plus x over square root of 1 minus x squared. But you can combine these because they have the same denominator, which is going to be 1 plus x, because you add the numerators when the denominator is the same, and you keep the denominator, so it's going to be 1 minus x squared, which is pretty cool. Alright, on to some implicit differentiation, which is pretty cool. So we're going to take the derivative of everything, and we're going to do it with, probably with respect to x here. So let's just do 3x squared, because if you can do it with respect to x, you can do it with respect to anything. And so these are both variables here. This x times y. So we're going to do a product rule. So we're going to keep the first and multiply by the derivative of second. And the derivative of y with respect to x is dy dx. dy dx. And let's see, we're going to again, so this minus sign is also for all of this, because that's just kind of how minus signs work. It's for this whole section. So we're going to have y and then the derivative of x, which is what is just 1. So don't forget, whenever you have a negative sign in front of like a product or a chain rule, but now we can do the same thing here. So this is going to be 3y squared dy dx. And then we have to write the derivative of y with respect to x. Dy, that looks like dx, but whatever. Dy dx is equal to 0. But we need to solve for dy dx. So we're going to now just distribute this negative sign here. And now we can get all of our things without dy dx as a coefficient to the other side. So we're going to have x dy dx. What is that character? Dy dx plus 3y squared dy dx. And then we're going to move everything else to the other side. So it's just going to be y minus 3x squared. And so here we could pull out the dy dx and divide by the other stuff. So, I'm just going to write the answer in green. So what I'm doing is I'm factoring out the dy dx and dividing by the x plus 3x squared, or 3y squared. Oh, this is a negative x. Oops. So y minus 3x squared over negative x plus 3y squared is equal to dy dx. And that is it. And then let's do this one. I'm kind of unsure where these parentheses are here, but I'm just gonna assume that the parentheses are here. So now we take the derivative of both sides. So the derivative of sine x is cosine x. And so there's no inside term either, so we can just leave it. The derivative of cosine x is sine x. There's negative sine x, so this negative becomes positive. So sine, but it is actually y. and then dy dx. And then the derivative of 2 is 0, and the derivative of 0 is 0. So we can move cosine to the right side. And so we're going to do negative cosine. Cosine x is equal to sine y dy dx. And then divide both sides by sine y. I will write this in yellow. Y prime, oh, that is an x. Y prime, or dy dx. I'm tired of writing dy dx, so is going to be equal to cosine x, or negative cosine x, over sine y. So if we did not want any things in the denominator here, we could also say that sine is, or 1 over sine is cosecant. So we can do negative cosine x and cosecant x. But I think this is going to be it for today.